Today we are going to learn about Docker networking, connecting your containers. You'll discover how to set up and manage Docker networks for effective container connectivity and security.
Welcome to our session on Docker networking, connecting your containers. In this video, we'll explore the fundamental aspects of Docker networking that ensure your containers communicate seamlessly, both within and across hosts. As microservices become increasingly prevalent, understanding Docker's networking capabilities is crucial for deploying robust applications. We'll cover various networking models, how to configure them, and best practices for maintaining security. Whether you're new to Docker or looking to refine your skills, this video will equip you with the knowledge to manage Docker networks effectively. Docker provides several networking models to suit different use cases. First, the bridge network model is the default and allows containers to communicate within a single host. It's ideal for standalone applications. Next, the host network model maps container networking directly to the host's network stack, offering improved performance but at the cost of isolation. Overlay networks are used for multi-host communication, crucial for distributed applications requiring containers on different hosts to connect. Lastly, the non-network model disables networking for containers, adding an extra layer of security by isolating them entirely. Selecting the appropriate model depends on your application's requirements, balancing performance, accessibility, and security. The bridge network is the default Docker network type, enabling containers on the same host to communicate with each other. It's isolated from the host's network, providing a secure environment for container interactions. By default, Docker automatically creates a bridge network called bridge. However, you can create custom bridge networks to enhance flexibility and control over container communication. To create a custom bridge network, use the command docker network create driver bridge my_bridge. This allows containers connected to my_bridge to communicate seamlessly. Bridge networks are advantageous for development environments or standalone applications where containers need to interact without external interference. However, they are limited to a single host, making them unsuitable for multi-host applications.
Overlay networks are essential for applications that need to span multiple hosts, such as in a Docker Swarm or Kubernetes cluster. They enable containers on different hosts to communicate securely, thanks to Docker's built-in encryption and isolation features. To create an overlay network, you must first initialize a Docker Swarm using Docker Swarm init. Then, use Docker network create driver overlay my_overlay to establish the overlay network. Overlay network supports service discovery, meaning containers can locate each other by service name, simplifying multi-container deployments. While they offer significant benefits in terms of scalability and security, they may introduce additional latency compared to bridge networks due to the complexity of cross-host communication. It's crucial to assess performance implications when designing your network architecture.
The host network model directly maps container network configurations to the host's network stack, providing performance benefits by eliminating network translation overhead. This is ideal for high-performance applications that require minimal latency. However, it sacrifices container isolation, potentially exposing containers to host vulnerabilities. Conversely, the non-network disables networking for a container, ensuring complete isolation. This is useful for specific security scenarios where network access is unnecessary or unwanted. Deploying applications that don't require external communication, like batch processing tasks, can benefit from the non-network. It's important to weigh the performance gains against the security risks and choose the network model that aligns with your application's needs.
Linking was one of Docker's original methods for connecting containers, allowing one container to access another's network information. This is achieved using the link flag, such as Docker run link container1: alias. While linking simplifies communication by automatically setting up environment variables for network access, it's considered a legacy feature with limitations. It doesn't support multi-host networks and lacks the flexibility of modern networking solutions. As Docker has evolved, network models like bridge and overlay have replaced linking, offering better scalability and security. It's advisable to transition to these newer methods for more robust and maintainable container networking.
Ensuring network security is paramount in Docker environments. Begin by isolating sensitive services using network segmentation, reducing the risk of unauthorized access. Utilize Docker's built-in encryption for overlay networks to protect data in transit. Implement firewall rules to control traffic flow into and out of your containers, using tools like Docker ziptables. Keep your Docker installation up to date to mitigate vulnerabilities. Regularly monitor network traffic using tools like Docker's built-in Docker Network Inspect or third-party network monitoring solutions to detect anomalies. By following these best practices, you can enhance the security of your Docker networks and protect your applications from potential threats.
Diagnosing network issues in Docker requires a systematic approach. Start by identifying common problems such as connectivity failures, DNS resolution issues, or misconfigured networks. Docker provides several CLI tools to assist in troubleshooting. Using Docker Network Inspect, you can view the network configuration and identify anomalies. For connectivity issues, the docker exec command allows you to run network diagnostic tools like ping or curl inside a container. Additionally, enable logging to capture network events and monitor for unusual patterns. By understanding the root cause of the issues, you can apply targeted solutions and ensure your Docker networks operate smoothly.
Docker Compose simplifies the deployment of multi-container applications by using a YAML file to define services, networks, and volumes. In your Docker Compose.yml, you can specify network configurations under the Networks section. For example, to create a bridge network, define networks, my_network, driver, bridge. Services can then connect to this network using networks, my_network. Run Docker Compose up to launch the application, automatically creating the specified network and connecting services. This orchestration streamlines deployment, ensuring consistent environments across development and production. Docker Compose's ability to manage complex networking setups makes it an invaluable tool for deploying microservice architectures.
Docker network drivers are essential components that determine how networks are implemented. The bridge driver, as the name suggests, creates bridge networks for container communication within a single host. The overlay driver facilitates multi-host networking, crucial for distributed applications. Another option, the Microservices driver, assigns MAC addresses to containers, allowing them to appear as physical devices on the network, ideal for legacy applications requiring direct network access. Docker also supports custom drivers, enabling integration with third-party networking solutions. Understanding these drivers' capabilities and limitations helps you choose the right tool for your networking needs, ensuring efficient and secure container communications.
Advanced Docker networking involves leveraging features like network policies for access control and service discovery for dynamic service resolution. Network policies allow you to define rules governing traffic flow, enhancing security in multi-tenant environments. Service discovery, facilitated by tools like Console or native Docker DNS, ensures containers can locate each other even as addresses change. For distributed applications, advanced networking setups integrate seamlessly with orchestration platforms like Kubernetes, offering scalability and resilience. As Docker continues to evolve, future trends indicate a focus on enhanced security measures and deeper integration with emerging cloud technologies. Mastering these advanced concepts will prepare you for the next wave of containerized applications.
In conclusion, Docker networking is a pivotal aspect of deploying and managing containerized applications. We've explored various networking models, how to configure them, and best practices for ensuring both connectivity and security. As you continue your Docker journey, remember that practical experience is invaluable. Experiment with different network configurations, and consider diving deeper into tools like Docker Compose and Kubernetes for more complex setups. Numerous resources are available online to support your learning, and the Docker community is an excellent place to seek guidance and share knowledge. Thank you for joining us, and we encourage you to keep exploring and innovating with Docker networking.